Hello there guys, welcome back to another video. Make sure that you do your full purple pen. Okay, so make sure that you show all your working out. Yeah, now why are we here today? We're here today to make sure that we know paper 1 ins and out, and we know physics ins and outs as well. Of course, again, without practice you can't improve, so therefore you need to keep practicing, keep improving your mistake, and then you are going to get there. So the earlier you start, the better it's going to be. So this way you are not going to have too much to revise at the end. Now let's take a look here. Now we need to work out the initial acceleration. Now what do we know is we know the forces on the object and we know the mass in this particular case. Now we need to use the equation of F is equal to ma. Now this F here, so this is for resultant force. Now, if you don't know it, now you know it, make sure that you write it down. Now, what is happening to this object? A metal ball is being held so that it is below the surface of the oil and it experiences an upward force of this much. Okay, now what is, when the ball is released, what is its acceleration? Now you need to ask yourself what's going to happen to this guy. Now the ball is released. Look at the weight. The weight is clearly bigger compared to the force on the top. So therefore, the resultant force is going to be 3, take away 0.3. So this is the resultant force. This will equal to the mass, which is 0.3. Again, do not confuse 0.3, which is this force, and 0.3, which is the mass in this case, multiplied by the acceleration, which we don't know. Now, 3 take away 0.5, 0.3, that is this, equal to this, and then you need to rearrange it, of course, divided by this, equal to A, and then A will give you 9. And the answer is going to be this one here. Again, if you don't know it, now you do know it. Make sure that it is indeed fixed up. Now let's move to the next one. Now, microwave is used to emit the TV signals from and to satellites, and satellites, they are located in orbit. Now the question is, which one is correct? Okay, now they have a longer wavelength than this, so this is incorrect. Okay, they penetrate the atmosphere without significant loss. They travel much faster in vacuum, no. Okay, they warm the satellite, no, so therefore by default it's going to be B. Now we know that microwave has the ability to go through the atmosphere compared to radio wave. Again, so radio wave, I'm going to write it down here. So radio wave are refracted slash reflected by atmosphere. Okay, so this is another piece of information. Again, refracted, so it means it's going to bend through the atmosphere and then it's going to get reflected as well. Now, question 3, here we go. Now, which one is the critical angle? So which one is showing the critical angle? Now, if you don't know the critical angle, we need to fix ourselves up. Now, critical angle is, I'm going to write it down. So in case you don't know it, now you do know it, and then you can write it down. Now, critical angle, it is angle of incidence, okay, when refracted ray is at 90 degrees. Now, where is the refracted ray? So this here is a refracted ray. So this is our refracted ray. So this is the refracted angle. So this is the refracted ray. Okay, refracted ray. So our refracted ray. So it is not this one because this is not 90 degrees. Now, is it this one? No, it's not 90 degrees. Is it this one? No, it's not 90 degrees. So therefore, it is this one. So look at this. So the refracted ray is at 90 degrees, and this here, this is our critical angle. So therefore, the answer is D. Now, if you got this wrong, again, have the definition written down, and then you know the answer in this particular case. Now, next one. What is going on here? Now, the satellite, this guy, is jumping off from rest through air and reaches terminal velocity. what is the acceleration during this fall? Now, when the guy, what happened? So as soon as the guy dropped, okay, so when the guy dropped, okay, so only the weight, okay, only the weight acts on it. So only the weight acts on it. So when this happened, the person start to accelerate massively, so it falls down massively. So it accelerates. Okay, how much is its acceleration? What is the maximum acceleration it can get? So this is acceleration due to gravity. Now, why is it due to gravity? Because the weight, yeah, due to gravity, and the acceleration due to gravity. You guys know that the acceleration due to gravity is 10 meters per second, or just 10 in this case, yeah. So you know it's 10. Now you have two options. You have this one, okay. You have this one. You have this one. So which is one is going to be? Now, as soon as start to fall, it's going to accelerate at 10. So therefore, you have two options here. You have option B and option C. Sorry, option D, because it is when it as soon as it falls, it's going to accelerate. So therefore, it can't be A is 0. It can't be C because C is starting at 0. So you have 2 points. Now, what's going to happen later on? Later on, so air resistance, air drag increases. What will this do? This will slows down. This will slows down the person. So if the person is slowing down, it means the person is decelerating. And eventually what happened? Eventually, the air drag equal to the weight, okay, and this leads to terminal velocity. And terminal velocity, it means the velocity is not changing, it's the same, so therefore acceleration is 0. So therefore the only option is going to be D, because the person falls, it accelerates, and eventually it reaches terminal velocity because of these air drag and the weight, both forces are equal, therefore there's no acceleration because there's no resultant force. Okay, now you know the answer. Again, if you got this wrong, have the full points written down, and now you know. Now, this is skipped, so this is something that we skipped. Now, if you've got the marks, then I've counted it, otherwise, I've skipped it. Okay. Now, the timber, this is pretty much the shape in this case. Okay, so this is the shape. Now, what happens sometimes you see on the oscilloscope is pretty much like a rectangle, the screen on it, and you see the wave going through. Okay, you can see the wave going up, and sometimes you see like zigzag waves. Okay, something like this, and sometimes you see some crazy wave like this. Okay, so this is just talking about the timber, which is the shape. Okay, so oscilloscope is used to demonstrate the sound. Which feature of the oscilloscope trace is affected by the quality of the timbre of the sound? So this is the shape, much. Okay, which feature is affected? The shape is affected. So if the sound is, let's say, louder, then you're going to see it in the shape. If and so on and so forth. Yeah, the shape will be affected. Let's move to the next one. Okay, so which device continuously steady output of power? Now this one depends on the sun, so this you need the sun, so not every day is sunny. This one needs wind, not every day is windy. Cell, now the cell run out, so therefore the only one is a nuclear reactor. Okay, because uranium is by default radioactive, it's going to continually to decay, and uranium is going to take like over 9,000 years, or maybe more, okay, or even crazy amount of time to completely decay, millions and so on and so forth. Yeah, okay. If you don't know the answer, you can go by process of elimination. Good. 7. Which statement is correct? Now they are absorbed by aluminum foil. No. They are deflected by electric field. Also, all are deflected by electric field. No. or deflected by magnetic field? No. So therefore, the only one is D. Now remember, ionizing. So they are called. If you remember what we did, they're called ionizing radiation. Okay, so ionizing. Yeah, I messed this up. Misspell this. Remember, when we did the topic, it was ionizing radiation. Okay, so all of them will ionize. Okay, radiation. Good. Ionize radiation if you know it is. Now for the first one, so what happened if you remember we have let's say paper or air, and then we have a little bit of aluminium, aluminium foiled or sheet, and then we have let's say concrete, or we have lead. So alpha particles, A for alpha particles, it can easily be absorbed by the paper or the air. Beta particles can go through paper and stopped by aluminium depending on the thickness. Okay, and then gamma can go through paper, can go through aluminium, and then it's going to be absorbed by concrete or lead in this case. Again, if you got this wrong, and here are the things that you need to write down. Okay, now density. So they have the same volume. So what we need to do is we need to work out the volume. So this one's easy. So density, rho, if you remember, mass over volume. Let's work out the volume. So it's going to be mass over rho. Now the mass you know is 390. Now why am I not converting it? Because I'm not converting it because density is in grams. Uh, okay, and the answer you see is already in grams, so I'm not going to convert anything yet. So this divided by this will give me 144.44 centimeter cube. And then what do I need to do? Then it tells me that the cooking oil, so the cooking oil this time is going to be same thing again. I'm looking for the mass. Mass would be density times volume. Now the density of oil is 0.9. The volume is going to be the same. Okay, so 144, and this will be 130 grams. So the answer is going to be A in this case. Good. And then let's go on to the next one. Question 9. Now, how do we know question 9? Now, compare a neutral atom in with this one here, a neutral chlorine and a neutral argon. Okay. Now, first of all, you know that chlorine on this one. So these guys, they are not isotope. Okay, so they are not isotope. Okay, so therefore they're not isotopes. So therefore, what can we say? Right. So if they are not isotope, it means that they will have so different number of electrons. So they are going to have different number of different number of proton. Okay, and by default, they're going to have different number of electrons. Now, how do we know they're going to have different number of protons? Now, they are neutral, yeah. So whatever number protons going to be, the same amount is going to be for the electron. So these two, they are not isotope, means they're going to have different proton, and then they're going to have different. They're going to have electrons as well. So for example, let me just okay. No, I'm not going to draw it. So therefore, we know that they are going to have different number of electrons. So you got option A and option B. Now, how about the neutrons this time? Okay, now let's take a look. So the mass number is 37 for this one. Yeah, for this one. That means that you need to have a number of electrons. Okay. Now let's say the electron for chlorine. I don't know. Okay. Let's say we don't know. Yeah. Let's say we don't know. So let's say it has 10 in it. Okay. So therefore, so this is proton P. Now what must be the number of neutrons for this guy? Okay, so the number of neutrons of this guy had to be 27. Okay, fair enough. Now, how about argon? Now, let's say for argon, we know that the total number, the mass number is 37. Now, since we know they are different elements, they are going to have different proton. So therefore, this number of proton is going to be different compared to chlorine. So therefore, this one is going to be, let's say, I'm going to make up a number there, let's say 5. Okay, so therefore, what number of neutron does this one need to have? So this one needs to have 32 in this case. So you can clearly see that if they're going to have different number of proton, therefore they're going to have different number of neutrons. So therefore the answer is going to be A in this particular case. Again, use logic. Logic is going to make you, it's going to save your life if you're not sure what to do. Okay, again, now this one, what is going to be the answer? What is the power? Now the power is, you guys know, power is energy over time. Okay, now energy is like work done, so work done dw over time. Work done is force multiplied with distance over time, so the force is going to be what? 6,000 multiplied by the distance 15 divided by 30. Okay, and this will give you a 200 watts, and then everything is fine, nicely done. Okay, and this leads us to, okay, all right, so this is a mistake. Yeah, this is a mistake. This is a mistake. Okay, one count, two. Okay, so this is going to be 3,000. Sorry. Okay, I fell asleep over there. That's why I made a mistake in maths. Okay, now let's take a look at this one. Now this is a good question here. So this is talking about the surface area. Okay, now the good thing, it tells you that in 1 second the solar panels is giving off this much. Okay, now what does this mean? This means that convert this joules to this in 1 second. What is the total area in this case? Now let's use this one. So what do we know? So this means that we have 120 joules, which is energy, okay, divided by meters squared. This is area, and this gives us 1 second. Okay, it doesn't matter. All right, so yeah, so this is what we have. Okay, so the total energy in 1 second of the group of this is this much joules per meter squared. The group of this convert this to this of useful power in this. So what is the total area in this particular case? Okay, so what we know, so therefore the total energy we put in is this much, and this is how much is being used usefully in this particular case. So therefore what we can say is, we can say that so this per this, okay, so we can say that the total energy that goes in is equal to the energy per area okay. Let me just delete this. Okay, deleted. Now per area, yeah. So what we know is, from this we know that's 200 joules is falling on 1 meter squared. Okay, so therefore 720 joules, this will be 1 over 120 multiplied by 720. Okay, and this will give me 6 meters squared. Therefore we know that for this much energy, 6 meters squared of area is needed. Now there are two options. There's option A and then there's option C. Okay, now the question is, we need to find the efficiency. Now efficiency, if you remember from the equation, is going to be useful divided by total time 100%. The useful energy is 220 over 7 this times this, and this gives me about 17%. So therefore the answer by default is going to be A in this case. Again, if you mess this up, here's the answer. Make sure that you write it down, so therefore you know. Balls filled up with air gently heated. Okay, what happened to the mass and density of the air inside? Okay, now we are heating up the mass. So the mass does not change. So you have two options. The mass does not change. Okay, so the only thing that has to change is the density. Remember, so this is equal to mass over volume. Right, now the mass stays the same. Okay, so what's going to happen when you heat up the volume? When you heat up the volume, what's going to happen? Sorry, when you heat up the gas, so the balloon gets bigger. Okay, the volume gets bigger, so therefore the volume is going to go up. Now, if the volume is going to go up, this means that the density of the gas has to decrease. Okay, so that's why the balloon is going to go up. So therefore the answer is going to be C in this particular case. Okay, so hopefully everything's sorted out. Now this is a nice question there. Okay, clockwise moment and anti-clockwise moment, so on and so forth. Which force is needed to rebalance the thing? So first of all, work out the moment of this one. So the moment here is going to be, moment is m, moment force times perpendicular distance. So this is this, so this will give me 18 Newton centimeter. So therefore, which one's going to be here? So therefore, force times distance must be the same. So therefore, the moment here, 30. Okay, let's have a look. So this is pushing down. So I need a force that is pushing down as well. Okay, because what's going to happen is this will turn it around, and this will turn it the other way. So they need to cancel out. So therefore, they need to be pointing downwards. So they need to be doing what? They need to be pointing downwards or upwards. Wait, let me just check. Downwards or upwards. Okay, so upwards. So here, this is upwards, and then this to the left of the. Okay, so this one to the left. Wait, here. Okay, so this on the left, this on the right. This is the right. This is the left. Okay, so we're placing a few things somewhere. Okay, right. Let's take a look. So let me start with the one on the right. Okay, so place one on the right here, and the force is acting upwards. Yeah, it can't be this one. Okay, now why it can't be B? Because B is telling you that you put something here, and this one is pushing up. So if it's pushing up, so you're gonna have you're gonna have a rotation. It's gonna go like this, and it's gonna go like this. So you're gonna have a full rotation. So it can't be B. Okay, by logic again. Let's take a look to the right and downwards. Okay, let's take a look to downwards there. What would be the moment of this one? We get rid of this. This moment would be 45 multiplied by 45. Okay, and this is 225. Okay, it can't be this one because the answer must be 1800. Okay, now all we left is, so it can't be this one, it can't be this one. All we left is the left side. So left side means we're placing it at the same side here. Okay, let's start with this one here. So place it 60 centimeter on this side, maybe. So 6 centimeter on this side, and the force is up. Okay, right now let's take a look. So we have 30 times this will give me 8 Newton. Okay, now this one here is going to be, let's take a look. So this one continue. So this is going to be anti-clockwise. So therefore I need one which is clockwise. So therefore if this one is here from the pivot, so this one will turn all the way up clockwise. So therefore this is clockwise. Okay, so this is the answer. In this case the answer is going to be A. Again, you see how I've done it. Okay, alright, because remember total anti-clockwise must equal to total clockwise moment. Alright, now I want my options in this particular case to find out. So the first option, A, works straight away. Okay, alright, let's move to the next one. What is this one talking about? Okay, so power. Okay, so power, we need to work out power. Okay, so power, well, power is energy over time, yeah? Blah, 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 power, so try to divert water from the river every single second. Okay, we know the mass of the water. Okay, we know the height being dropped to the height h. We know that the efficiency is this much. Gravity is given to me. Okay, how can I work this out? Okay, good. So energy. So the water is coming from above. So the energy will be gravitational potential energy. So mgh over time. Now m we know is 20. Okay, gravity is 10, gives it to me 15. Okay, and the time. What is the time? So that is the thing I need to know. What is the time? Okay, so the time is 1 second. Where is it? Every single second. So time is going to be 1 second. Okay, so let me just plug this in my calculator. So 200 times 15. Okay, that is 3000, and this is 60% efficient. So therefore, this is going to be time. I need to time this by 60 because 60% efficient. Therefore, my answer is going to be. Oops, that's not the right one. The answer is going to be. So power will be this much, 1800 in this particular case, and the answer is going to be in kilowatts. Therefore, it's going to be 1.8 kilowatts. So the answer is going to be B in this case. Again, if you've got this wrong, make sure that you do fix it. Okay, and hopefully you're learning something as we go along. If you missed anything up, force is forward. So let me draw force here. Force forward. So the force here is 20 Newton forward. The mass we know, 5 kg. Second force which acts on the object, and the forward acceleration is this one. So the object is still going forward with an acceleration of this much here. Now, where is going to be the force? Now, we don't know whether the force is going to be in the same direction or will it be opposite direction. So we don't know whether the force is going to be F resistance or not. So what we're going to do first is we're going to do F equal to ma. Now remember, this F is the resultant force. Okay, so what we're going to do is we're going to work out the acceleration first of all from this here. Okay, no, actually, no. Let's work out the resultant force first. Okay, and then we'll find out. Okay, so the mass is 5 times acceleration, which is 3. This is 15. So therefore, the resultant force F resultant is 15. Now, the force that's being pushed forward is 20. And how is it that the resultant force is 15? So it means that the second force, has to be in the opposite direction. So therefore, the opposite force has to be backward. You have 1, 2. Okay, so therefore it's going to be so resultant force is going to be 20, take away F, which is the force we're looking for. So resultant force is 15, 20, take away. Okay, so F is going to be what? So what force take away F is going to be 5. Okay, here we go. Again, if you got this wrong, make sure that you know it and then you fix it up. Okay, this one is nice and easy question. So we have 270. So after half-life point, so this is 1 half-life. Okay, so after half-life, 1 half-life. Okay, so if after the first half-life, so this thing is going to half itself. So it goes down to this. After the second half-life again, this is the second time, it's going to half it again. Okay, it's going to half it again, so 118. After the third half-life, it's going to bring us to 90 in this case. Now we have 1, 2, 3 half-life. So each half-life take 24. So therefore 24 hours multiplied by 3. Okay, and you guys know maths better than I do. Therefore we end up with 72 hours. Okay, so therefore the answer is B. How easy it is, this is. Okay, they're giving you 3 marks there. Okay, and we need to take it. Right, now vector and scalar. Which row is the size of the vector equal to the size of the scalar? So the size meaning the magnitude in this case. Okay, right, the size, let's take and displacement and velocity. Now this is meters per second, this is meters. No. Velocity and distance traveled. This is meters per second. No. Velocity and speed. So this is meters per second, this is in meters per second. Okay. Now weight, this is in Newton, mass in kg, so therefore the only answer is C. Okay, you see how easy it is to do this? Amazing, isn't it? Next one. Okay, what do we have here? Now, this shows the resultant force of this and this. Okay, so this is a resultant force here. The angle between this and this can be any value between so this angle here could be any value between 0 and 8. Which value is not possible? Which value is not possible? Very, very amazing, isn't it? So which value is not possible? Now, how can we work this out? Okay, so how can we work this out? Okay, now what we're going to do is we're going to take the extreme. Now this is going to be a little bit far-fetched, but you know what, we're doing physics anyways. Let's use logic. Now it goes from 0 to 90 degrees. Now if the angle is 0, you have 4 here, and you're also going to have 3 here. So therefore the force, the resultant, is going to be 3 plus 4, 7 Newton. Now this is the minimum value you can have when the angle is 0. Okay. Now when the angle is at 90 degrees, it's going to be like this. So this is 3, and this is 4. So therefore, oops, let me just do it this way. So this way will make it easy. So when the angle is 4 and the angle is 90 degrees. Okay, so 90 degrees. So this is 3, 90 degrees. So this is going to be the resultant force in this case. Okay, or whichever way you're doing it. So therefore the resultant force in this case is going to be Pythagoras theorem. So resultant force is going to be 3 squared plus 4 squared, square root the entire thing. Okay, so 9, 16, 5, 5 Newton. Okay, so you see that is going to be what? Now we know that when the angle is 0, the value you can have is going to be 7. Okay, so therefore by default, now the question is which one is not possible. So it can't be D because D is possible. 5, it can't be 5 because 5 is possible. Okay, and now look at this one here. It means that, so when the angle goes from 0 to 90, okay, and what did we just do? We did 290, yeah, 290 goes 290. It means that the value is going to go from 7 to 5. So any value between 7 to 5 or 5 to 7 is possible. So therefore, it can't be C. So the only answer is going to be A. So this here is possible. Okay, here we go. So what you need to do here is we need to work out the possible to work out the impossible. Does this make sense? Because now you find out the impossibility of the possibility in order to do this impossible question. Okay, now it's possible for you to move on. Okay, question 19, earthquake. Amazing question. Now, if you remember, there are 2 types of earthquake. You got the P wave and you got the S wave. Now, P wave is longitudinal waves. S wave is transverse wave. Now, how do we know which one's which one? Now, transverse wave, you know, it goes up and down. So like an S, so that's how you can remember it. Okay, now, where is this thing? The solid earthquake travel from solid surfaces. Okay, the solid surfaces vibrate. How can it be described? Okay, now this here longitudinal wave is going to go through both solid plus liquid. Okay, now this one only liquid. Okay, sorry, my bad, only solid. Okay, so therefore it's going to be D in this particular case. Okay, right, and then where is it? Earthquakes through solids from east to west. Earthquakes are from east to west. The solid surfaces vibrate in north to south. Okay, so if you remember the Earth like this, so if the earthquake is going from, where is it? East to west. So from east to west, to east to west. It's saying the solid is vibrating in the north to south direction. In the north to south direction. North, south direction. North, south direction. Okay? And this is going up and down, up and down, up and down. Okay? Now let's go down. Okay, so this one, guys, so this one should be straightforward there, yeah? Okay? Okay, so you should not be sleeping. Okay, now let's take a look. Right, so light bends towards normal in glass. Glass is dense, okay, plus bends away in air. Okay, again bends away from the normal. Yeah. Now all you have to do is, let me see if I can do this. Okay, we're going to orient our paper. Let me go down. Okay, one more. Here we go. Let's zoom in now. Okay, because I need this to draw my normal. So normal is going to be perpendicular to the surface. Dot 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 dot. I'm going to do the same thing here. Dot 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 dot. Same thing here. So this is the first normal. So 90 degrees, 90 degrees, and then here as well. Dot 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 dot. 90 degrees. Dot dot dot. 90 degrees. Dot dot dot. 90 degrees. Now, when the wave is entering the glass, so this is a white light wave. It's going to start to disperse. So look here, there's no dispersion, so it can't be this one by default. Okay, so we also have this one here. Okay, dot 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 dot. Okay, now look at this one. This one here, it bends away from the normal. But glass is dense, so it can't be this one. Okay, now you're left with two options. You're left with option A and option B. Now let's take a look what we got. Again, normal here. Normal. Now what we do know? We know that when the wave goes in the air, it bends away from the normal. So here, so this is not, so here, not bending at all. So therefore it can't be, so not bending at all. So therefore it can't be A, so it can't be B. Look at this now. This one is bending away, this one is bending towards, so therefore the answer is going to be A in this case. Again, so this is how we use the brain power. Next one. Okay, amazing question, this one. Amazing questions. Okay, let's take a look what we got. Okay, guys, so come on, this one's straightforward there. Okay, this times this is equal to, again, now the moment is going to be 3 times d bracket plus 0.5 times 100. Okay, and then we rearrange. D is going to be 0.2 in this case. Okay, so 0.2 c. Okay, again, so remember, so this is the moment for this one, and we have this moment from the pivot, and then we have this whole thing here. Again, so the total clockwise moment, total anti-clockwise moment, nice and easy stuff there. Okay, now what is happening in this particular case? Constant speed, so means no acceleration, and this means balance. Force means zero resultant force. Okay, now there's a change kinetic energy. No, nothing to do. Nothing. Okay, the work done. Okay, right. Okay, my bad. Work done is energy. Okay, so the energy by the cyclist is equal to what? So the work done, so the energy that you are using is by what? The force of air resistance, no. Friction, no. Change in kinetic energy, no. The thermal heat produced the thermal heat produced. So it means that the work that you're done, that you're doing to cycle, is the same is the same as the heat that you're producing. So the more heat you produce means that you're working hard. The more work you're doing. Okay, yeah, that makes sense. Okay, nice one. Okay, let's go to the next one. Okay, if I do it, gravitational potential energy, the weight is 500, gravity is 10, the height that's gone up to is 3, even though, okay, so we're going to do is there, okay, yeah, this give me 15,000, that is not of the option, yeah, that's not the option, so this is something strange there. Let me work out the work done is force multiplied by the distance, the work done, okay, the force that is putting it is 400, now the distance which is travel is going to be 5, okay, so this is 20,000, okay, joules, okay, so 20,000 joules there, okay, right, and then we need to work out the work done. Now let's take a look. Part of the work done increases the gravitational potential energy, okay, and the rest is work done against friction. So part of it is to increase the energy. So energy is work done, and the rest part of this is the rest is work done. Is the work done plus friction, or is it work done is increasing the energy plus the leftover is friction? So this means that the work done is going to be greater, which is not the case. Okay, so this is the one. So the work done is part of the gravitational potential energy. Okay, this is part of this, and then the leftover is turned into friction in this particular case. Okay. Okay. Interesting. But still, this is too much. It's too much. Let me have a quick check. If there's anything else. Okay, oh my god, I made a extremely silly mistake. Silly mistake here. Silly mistake here. Silly mistake. Silly mistake. Okay, so mgh. This is the mg, which is the weight. So the 500 is already the weight. There's no need to multiply by 10. Okay, so mg, that is the weight. 500 multiplied by 3, this is 1500. So therefore now we're talking about A or B. Okay, now let's take a look at this one here. Now the work done is, what is the work that is being done? Okay, right, now let's take a look at this one. Now the total work done when we calculated it is 2000. Okay, now however the question is hinting us that there is indeed friction going on. Okay, all right, now what's happening here? Look at this. So from here to here, the work done, what we calculate is 2000, isn't it? It's 2000. So this is the total work done. That is actually 2000. Okay, now however when we work out the gravitational potential energy, it is only 1500. So it means from here to here is only 1500. So what is happening? So okay, So Y energy is lost. This is due to friction. And this tells us that the friction thing is the work done against the friction. So therefore, we're going to do 2000 take away 1500, and this will give us the energy that is lost by friction, and this is the work done by against friction. So this is going to be 500 newtons. So therefore, the answer is going to be A in this case. Okay. Again, if you got this, for those of you got this correct straight away, well done. Okay. So even I had to pause a little bit for this one. Okay. All right. Let's move to the next one. Very happy there. Okay. What is this one talking about? Result of force. Blah blah blah. Okay. Which one has the greatest power? All right. So power is energy over time. Okay. There's force there, so therefore it could be force is the work done, force time distance over time. Now everything is 10 seconds, and everything is 10 seconds, of course, and everything is in so 10 seconds. So therefore power is force, which we don't know. We're going to find out that distance is 1 meter over 10 seconds. So therefore it depends on the force. Okay, right? Or you can work out every single power. Now let's take a look. This one. So let me do this. 0.1 F. So this one's going to be power is going to be 0.1 times 12. This one is in the same direction. Be 0.1 times 8. Okay, this one is going to be 0.1 times 10. Okay, and I think by default you know that A is going to be greater, yeah, because A is everything is 0.1 times the number, which is 12, and 12 is the biggest one here. Let's move on. Okay, mass, gravity G, field strength, how much force is needed, F is needed, blah blah blah, acceleration. How much force does the flow of the lift exert on the person when it accelerates upwards? Okay, yeah. Now remember when you go in the lift, and when the lift starts to go up, you feel heavy because the flow, when the lift is going up, the flow is also pushing onto you in this particular case. Okay, now first of all, I want to work out how heavy you are going to be. So mass times g, so therefore 60 kg you are times 10, so therefore 600. That is your weight. So this is the weight this is your weight. Your weight is 600 Newton. Okay, and next one, I want to know the force that you're going to exert when you accelerate ma. So this is going to be 60 times 2. So this is the upward acceleration. So this would be the Newton. Okay, all right. How much force does the flow exert in this particular case? Okay, so therefore the total was how much force does it exert when it is lifting up. Okay, right, so therefore we need to add them together. So the total is going to be 6. This. There we go. Okay, right. So what happened is this is your mass, yeah, and the lift has to move up 2 meters per second squared, yeah. So therefore, this is how much force you need to exert. Okay, so this is how much force you need to exert in this case. Now also, you need to push against 60,000 newton, 600 newtons. Okay, so you add them together and you're done. All right, move to the next one very quickly. Okay, so this is so 2 balls, just spherical balls. P Q mass is 5. This is 1. Same height, same time, blah blah blah. Why do they have the same acceleration? Like acceleration is the same. So acceleration is the same. Assume they are on Earth, so g is going to be the same. So g is going to be the same. So 10 in this case. So what is different? So therefore, let's have a look. Weight is going to mg. Weight is going to mg. So gravity is the same. That's 10. Okay. So let's take a look. So therefore, this is going to be 5, 10 to 50 Newton. This is going to be 110, so this is going to be 10 Newton. Okay, so therefore, okay, so this one, the force is times 2 is double. So P is doubles. Wait, okay, my bad. 0.5, yeah, 0.5. Making mistakes, so this is going to be 5 Newton. So this one's half. So this one, the force of this one is 2. So therefore Q, the force is double. Okay, because the mass is different here. So gravity is the same. So therefore the only thing for it to work is the force has to be the double. Okay, so the answer is C27. Vibration. Come on, you guys know this one here. Okay, why is the best? Metal has free conductor, free electrons, delocalized electrons. You guys done this. That's why it's better. Okay, that's what the question today. Why is it better? Okay, so 28. What is the work done against gravity? Okay, let's do this very quickly. Okay, force times the distance. Okay, so do we know the force? The force is going to be the mass times g times d. 6 times 10 times 1.5. Okay, all right, so 900. The answer is going to be C. 900. Let's move on very quickly. Okay, very quickly. Okay, what do we got? So what do we have? What do we have? Okay, right. So what is the density of P? Okay, now they have the same mass. Okay, so density is mass of volume. Density is mass over volume. Now the mass is the same. So mass is rho. Volume, same thing there. Okay, so the mass is the same. So therefore, it's going to be. Let me see. P. So mass of P is equal to mass of Q. So therefore, the equation is rho times volume. Rho times volume. Now the rho of what's this P? We don't know. I'll just leave it there. The volume of P. So what is the volume of this one? So we got this. What do we have here? The volume of P is going to be the area multiplied by the height. So the area, call it A, area multiplied by the height is H. Now this density here, do I know? I don't know this density here. Okay, now the volume here is going to be the same, so same area, so times A multiplied by the height. Again, so this is the cylinder, yeah, the area of the cylinder, the area of the circle times height is 3h. Okay, so therefore now I'm looking for this one. So this one I'm looking, so this is the P1. So P is equal to rho, so this is the rho for the Q. A times 3h divided by A h. So this would be rho. This cancel out, this cancel out, this cancel out, this cancel out. So this would be 3. In this case, so the answer is going to be C. In this case, again, so be careful here because we're doing rows there. So therefore, the density for P is going to be 3 times that of the density of Q. Okay, now this one's going to be straightforward. What are we looking for? Critical angle. We've done this already. So the critical angle of for light in the water is going to be B. Again, you can see that this is 90. The refracted ray, so refracted ray is coming at 90 degrees. Therefore, B is going to be the answer. Okay, so building is made up of wood and steel. Blah blah blah. Through the wall. Okay, through the wall. Let's take a look. So we've got the wall here. Okay, it's got buildings made up of wood. Steel. Conduction through the wood. So conduction does take place through the wood by movement of molecules through the wood only. That is incorrect. So conduction takes place in all solid through the metal by both vibrating and moving through the steel. Okay, so both vibrational particles. That's correct. Okay, so through the steel, through the metal, vibrational particles. Good. Now steel is a metal, so steel is going to have electrons, the free electrons move. Okay, conduction through the wood, both vibration movement of through vibration movement of molecule through the wood. Vibration and movement. No, the particles in solid they are close together, they don't move, they only vibrate. Movement of 3 electrons only, no, so therefore the answer is going to be B. Okay, now electrons move because electrons is free. The particles only vibrate because the particles, they are fixed in the position. Again, if you got this wrong, you need to fix yourself. Okay, now this one is fine. If you remember, we have the, okay, so let's have a look. We have, okay, now remember, wait, we need to go in order, isn't it? So first of all, we have to burn coal. So this is the first one. We need to burn it. So once we burn it, we are going to make the water hot. Once we make the water hot, we are going to turn the water into steam. So water is going to turn into steam. Okay, so once water is turned into steam, we are going to, the steam is going to turn the turbine. Okay, the steam is going to turn the turbine. It's 3, it's going to turn the turbine, and the turbine is going to turn the generator, and therefore the generator is going to make electricity. This one's straightforward. Okay, this is pretty much what you did in year 7. Okay, now which one reduces heat by radiation? So radiation, we need radiation. Okay, so radiation. Okay, now let's take a look. So there's empty space here. Okay, so this empty space, okay, block conduction plus convection. Okay, so it blocks this. Okay, now what do we know? What else do we know? We know the vacuum within the wall reduces radiation. No. Okay, so allows, so block conduction allows radiation. Okay, allows wave to go through, the heat wave. Okay, now if they choose to paint, let's go option B. Paint Q black. So if Q is black, I'm not sure what it's talking about. Okay, so this is black. Now black equal to good absorber and good emitter of heat, isn't it? Okay, so it can't be black because black is going to absorb the heat and then it's going to radiate the heat as well. Now R is black. Okay, so R is black. So if this is black, so this will absorb the radiation coming from it, and then it's going to emit it as well. Okay, so it can't be this one. Okay, because it's going to absorb it. It's going to absorb it easily. So it's going to take all the heat that's coming from the water by radiation, going to absorb it. Now this is the heat lost by, and this is silver. Now silver reflects the heat. So if the heat gets to silver, it's going to reflect it. If the heat gets to silver, it's going to reflect it. So silver or shiny surfaces, they are good reflector of heat, poor absorber. So it makes sense for the answer to be D. Again, if you got this incorrect, make sure that you do fix your work here. Okay. All right. So this should be the last question. What is the speed of the tool that hit the surface of the moon? Okay, let's take a look. We got astronauts, blah blah. The mass we know from rest. So this is initial velocity, which is 0. Kinetic energy we know. So Ke is there. What is the speed at which it's going to hit the moon surfaces? So the final speed in this particular case. Okay, now let's start with what we know. So Ke, okay, mv squared. Okay, now the initial velocity is 0, so we don't need to worry about this. So therefore, it's going to be Ke multiplied by 2 equal to v squared. So Ke, so 2Ke over equal to v squared. So 2Ke over m square root is equal to v. So therefore, v is going to 2 over the mass. Okay, let me ask my friend how much would this be. Look for the answers there. Okay, if you got this wrong, again, make sure that you fix everything. Okay, so loads of stuff there. It's very, very good for your brain power boost. Peace out.